Now that we've added the animated grabbed section of the building to our simulation, let's set up the delayed activation for the section at the end of the shot. So if we take a look at this rendered version of the shot here, you can see when his hand pulls away from the building there's a portion of that building that falls away, as if he kind of tore it off with the motion of his hand, or it was kind of held in place as his hand was pressed against the building. And that sort of delayed activation really makes for a much more interesting shot overall. Now setting up that delayed activation is quite straightforward. We can just go to our sim attributes wrangle just before our sim pieces, and we'll add another activation check here. We can just copy that bit of vex that we added for clump number 10,001, and we'll add another section for clump 10,002. However, for that clump, we don't want it to activate at frame 1026. I chose to activate it at frame 1074 instead. As for the constraints on this end activation section, we don't want to completely delete them and let all the pieces completely fall apart, but we don't want to keep it as one massive chunk there either. Instead, I'm going to break up that massive chunk of constraint into a few smaller sections, but with still some large interesting features like you can see in this render here. Now if we go back to our constraint portion of the sim setup, we can drop in a split to separate the constraints for section 10,002. You can just specify at clump equals 10,002 in that group and make sure the group type is set to points. And to keep the scene clean, I'm going to use a subnet to break up that end section. I'll call it break up end clumps. I'll connect the end section split to that, and then we'll just merge it with the second output of that end section split. So now if we take a closer look at just this end section and dive inside our subnet, I'll also turn off the creature display for now. Now in the subnet, I'll start by creating a null for our input constraints. And I'm going to select the ones to keep using geometry grouping, kind of like we did for defining the clumps in our constraints. So I'll scatter some points onto our constraint geometry. You don't need to scatter very many. In my case, I just scattered 11 points. As usual, you can play around with the seed if you'd like. And then we can copy some spheres to those points. On that sphere, I'll set it to polygon, maybe a frequency of 5. And I'll drop in that copy to points SOP. The sphere in the first input, points in the second. You can also use an attribute randomize to modify the p-scale a bit if you'd like. And like before, I'm going to use an attribute noise to distort the shapes of these spheres. And then I'm going to convert these to VDBs in order to select our constraint geometry. Anytime that you have overlapping geometry like this that you're using for grouping, it's much more reliable to convert it to a volume first, since all of that intersecting geometry can mix up the grouping. So now we can create that group, and I'm just going to call this keep. We'll connect our input constraint geometry to that and the BDB to the second input. Group type is points, base group off, bounding regions on, and bounding volume on. And if you display that, you can see the selected points, and we'll drop in a blast SOP. And on this blast SOP, you can select that keep group, and we'll select delete non-selected. And as always, when working in a subnet, make sure to create an output at the very end of that. And now we have some nicely broken up constraints for that end section that will still preserve some cool looking large chunks and clusters. Now in my version of the sim, I made a few more tweaks before running this. On the sim attributes wrangle, I specified an Excel max and an Angular Excel max of 20 and 15 respectively. Don't feel like you have to use these numbers. These are just what worked out in my simulation, and you can feel free to experiment with different values yourself. You could try leaving out this Excel max entirely and see what it looks like, see if there are some out of control behaviors and collisions, and then at that point try to tame them with the Excel max values. I also increased the gravity a little bit. I like just using a multiplier in front of the standard value. I just used slightly more than normal in this case, turned it up to 1.2 times that normal gravity value. And for the RBD packed object properties, normally I make a point of turning down the bounce on this physical tab, although in this particular case I just left those things at their default. But it's very important that we turn on this overwrite attribute option once again. We turned that off before when we weren't using activation, but now that the active value is changing on different sections of our geometry at different times, we have to make sure that's overwritten from the attribute in SOPs. However, we don't need to overwrite the animated or deforming attributes. So now with those changes applied, we can display our DOPNet and template display the static portion and bring back that monster, and go to the render camera and do a flipbook of our new simulation. Now when running this updated sim, we ran into some obvious problems. Those sections that we set up delayed activation for when his hand hits the building and for the end of the shot look like they're active all the time. And I kind of like running into little problems like this so you can see what some of the potential problems are and how you might go about debugging those. So let's check the active values at the start of our sim. So I'm going to go to the sim pieces null and drop in a blast. And in the blast I'll type @active equals 1 and flip the group type to points and connect that to our sim pieces. Now you can see all of our sim geometry has been deleted. We can only see our templated static portion of the building. And we're expecting to see the section that his hand grabs and the section at the end of the shot to be non-active at this point of the sim. Now what's causing it in this case is because we're checking this clump value to delay that activation. And if you middle mouse on the merge node just before we set those sim attributes, you can see clump is a primitive attribute, but we're setting active on point attributes. And when the vex runs and checks this clump attribute on points, it doesn't find a clump attribute, so it just creates one, and that's not going to have the correct values. So we need to make sure that we promote our clump from prims to points so that we can query it in this attribute wrangle. Now we already have an attribute promote here that we're using for the name, so we can just move that in front of our sim attributes and include the clump in our promoted attributes. So I'll select that from the drop down, and once we promote that clump, you can see that our active blast SOP there is showing our hand grabbed piece and the section at the end as inactive pieces at the start of the sim. So now with that fix applied, I'll go back to the DOPNet and then rerun this flipbook. So now that we fixed that activation problem by promoting that clump attribute to points, when we rerun that simulation, it looks a whole lot nicer. You can see the activation is working correctly for the end section and the section grabbed by his hand, and overall the simulation is much more interesting. There are still some problems in this sim, such as that popping on the end section when it's activated, but next week we'll cover some post-simulation tweaks that can help fix some of those issues, so don't worry too much if there are some little imperfections in the simulation like that. And also, it's always important to remember that a lot of this is going to be covered up by the dust, so don't feel like everything has to be perfect at this stage. However, our simulation is currently running pretty fast. In my case, this was about a 20-minute sim here, and you can potentially increase the quality of your simulation by going to your DOPNet and increasing the number of DOP substeps. The bullet solver is already doing its own internal substepping. If you go to that bullet solver here, you can see this is defaulting to 10 bullet substeps, and adding some .NET substeps as well will force even more iterations on all of those substeps. So this might be overkill, but since our sim really isn't too slow at this point, I'm going to turn the substeps up to 4, and I'll cache out this simulation and then do a flipbook with the high-res building to see what that looks like. And now, after increasing my substeps and displaying the high-res geometry for the flipbook, the new version is looking like this. You can see the end portion in particular still pops a little bit when it is activated, but it's not nearly as bad as the bad popping we saw with the last version without the substeps. It looks at least a little bit improved.